All right, this is the last section in the chapter, so we're almost ready for a test, okay? 3-6, perpendiculars and distance. There's a few things that you maybe didn't realize. You probably knew it, you just didn't know you knew it, kind of a thing. The definition, distance from a point to a line. Okay, the distance between a line and a point not on the line is the length of the segment perpendicular to the line from the point. What that says is, okay, we have a point and a line, all right? The distance from this point to the line is the perpendicular, right here, okay? The reason for that is because if not, then we could all measure things differently. I could be like, well, it's this far, it's this far, it's this, do you see what I'm saying? So it's always the perpendicular because that's only one answer. So the distance from a point to a line is always the perpendicular, okay? Perpendicular postulate. If given a line and a point not on the line, then there exists exactly one line through the given point that is perpendicular to the given line. That's literally what I just said. I just said the reason that we do this one is because there's only one answer. That way everybody gets the same answer, or we should, okay? Distance between parallel lines, same concept, but the distance between two parallel lines is the perpendicular distance between one of the lines and any point on the other. So if I have two parallel lines, and I know they're parallel, either know their slopes are the same or they have the little arrows on them or something, I pick a point on this line anywhere I want. Doesn't matter. Pick any point. And then I would find the perpendicular, and this is the distance. That will make more sense when we do an example. So just kind of give me a second. Overall, the concept is distance from a point to a line is a perpendicular. If it's not making a right angle, if it's not opposite flip slope, then it's not right. Okay? In a plane, if two lines are equidistant from a third line, then the two lines are parallel to each other. So you have a picture, right? Look at yours. Do you guys see the two lines and the third line? So I'll draw it too. In a plane, if two lines are equidistant from a third line, then they must be parallel to each other. So if this is 2 and this is 2, and we have these because I wouldn't have known it, then they're parallel. Even though they look parallel, I know that they're parallel. Is that okay? Okay. So let's do some. When you're constructing a perpendicular, it could be inside the figure, it could be outside the figure, or it could be on the figure itself. So just keep that in mind, okay? So I'm going to construct the segment that represents the distance indicated from Q to RS. From Q to RS, I need to draw a perpendicular. That's going to be outside the figure, right? So I'm going to extend line segment RS. Everybody see that? For me to make a perpendicular line to it, I'm going to go right here. Does everybody see what I just did? From Q to RS, I had to extend RS. That was the only way to do it. So it's outside the figure. Do you guys see that? That's supposed to be really easy, really quick. Okay. On H to FG, it's going to be inside the figure. Is that okay? Had they said G to FH, I would have extended it and I would have gone this way. Do you see what I'm saying? So it depends on the question how you're going to do it. Inside, outside, on. If it was an actual right triangle already, it would have probably been on it already. So you've got inside, outside, or on. Is that okay? Okay, easy, right? So line L contains points 1, 5, 4, -4. Point P has coordinates -1, 1. Your directions, I assume, say find the distance between the point and the line. Yes, find the distance from P to line L. So there's a lot of different ways to do it, but I really think that having a graph is probably the best. And I need to grab a graph. I guess I don't have it. I thought I had some. So I already told you guys to graph it. Oh, there it is. Just kidding. Okay, perfect. So where are we at? 1, 5 is right 1 up 5. And 4, -4 is right 4 and down 4. And that's line L, right? Okay. So connect it the best you, pretend that looked better. Connect it the best you can. And then P is at -1, 1. So always label things. So this is P, this is line L. Okay? I can show you the algebra, but we can also kind of figure it out too. So I'm going to try to do both depending on the question. To find the distance from P to line L, we have to find the perpendicular. So if I find the slope of line L, right, I could find the opposite flip, opposite reciprocal slope, and that would be the perpendicular, wouldn't it? So mathematically, I can do it that way, or I can do graphically, which is what we're doing now. Let's find the slope of line L. I'm going to count rise over run. Okay, easy algebra 1 stuff, right? If I count rise over run, help me out. That's down, is that 5 already? And then that would be 4 more, so isn't that down 9? Is that right? And then right 1, 2, 3. So I'm going to say slope of L, we said down 9 and right 3. Is everybody okay with that? You always, always, always reduce. So what's the slope of line L? Negative 3, right? So the slope of line L is negative 3. If I wanted the perpendicular slope, because I have to do perpendicular, it's going to be opposite reciprocal. What's the opposite reciprocal of negative 3? 1 over 3. Does that make sense? Okay. So from P, I'm going to go up 1, right 3, and see where it hits line L. However, if we're going to do it graphically like this, we have to be very specific. I don't want to guess where they cross. I want to know where they cross. So if I'm going to do it this way, I know that my slope is really down 3 and right 1. I know I only need 2 ordered pairs to make a line, but I'm going to put a bunch more on there just to make sure that I'm finding the actual intersection point. Does that make sense to you? So I'm going to go from here, down 3, and right 1, because see, my line wasn't great. I'm hoping yours was better, but still. I'm going to go down 3 and right 1, down 3 and right 1. So I have as many ordered pairs on there as I need, I feel like. So if I'm going up 1 and right 3 from P, up 1 and right 3, look, they cross here. I'm not guessing. They both touched this ordered pair. Do you guys see what I'm saying? Okay. So I'm going to draw my perpendicular line. I'm looking for this distance. Does everybody understand what's happening right now? Okay. So I know that P was at where, negative 1, 1? Negative 1, 1. And this is, where's this one? I can't see, is that? I think it's 2, 2, isn't it? Is it 2, 2? Okay. So I'm trying to find the distance between these two ordered pairs. How do we find the distance between two ordered pairs? Distance formula or Pythagorean theorem trick. Pick one, right? I think you guys are pretty good at the Pythagorean theorem trick, so I'm going to do distance formula just to keep you refreshed on both options. Is that okay? And plus, that's a pretty small little space, so I feel like the Pythagorean theorem trick is fine. It'll still work, but I think when it's that little, it's kind of easy to get confused. So I'm going to do distance formula, okay? So distance formula, if you've forgotten, distance equals square root x2 minus x1 quantity squared plus y2 minus y1 quantity squared. You can do Pythagorean theorem trick too. Either way, it's totally fine. Okay? If you guys want me to go back and do that in like green or something, let me know. All right? So I've got x1, y1, x2, y2. You guys get it. Doesn't matter though, as long as the x is first and the y is second. Right? So I'm going to say, I'll do 2 minus 1 squared plus 2 minus negative 1 squared. So even though you haven't done that in a while, most of you guys do the trick, I think, at this point. Are you okay with what I just did? I'm just going to substitute, right? And I'm not going to use my calculator. These are pretty easy numbers. What's 2 minus 1? 1 squared. What's 2 minus negative 1, which is really plus positive 1? 3. What is 1 squared? What's 3 squared? So I get square root of 10. The distance from P to line L is the square root of 10 units. I'm going to talk about all that again, okay, because that was kind of a lot of stuff. It's stuff you know. You know how to find slope. You know how to find perpendicular slope. You know how to do distance formula, but it's all together. Thank you. Thanks. So one more time, here's what we had to do. Obviously graph the thing. Even if that's not how you're going to solve it, I still would graph it just so you kind of see what's happening, okay? I found the slope of line L, and then I knew I needed the perpendicular slope, so I took the opposite flip, right? So the slope of this was negative 3. I put a lot more ordered pairs on it, so I wasn't guessing where this crossed. Okay, you don't ever want to guess. So when I did the opposite flip slope, I know that they both touched that ordered pair. That was their intersecting point. All right? So I found the distance from P to the intersection point using the distance formula, right? But you could have done Pythagorean theorem trick. Either way would have been fine. Is everybody okay? So that's like the easy one, because they both crossed at the same point, so I wasn't guessing, okay? So let's try the next one. Find the distance between each pair of parallel lines of the given equations. So on this one, show me on your arm the y-axis. What's the y-axis? The vertical, right? So what's a y-line? Horizontal. Very good. So y equals -2 is on the y-axis at -2, and it's a horizontal line. Okay? And we label everything. Y equals -2. And then y equals 4 is on the y-axis at 4 again. Horizontal line. Label everything. Distance is always perpendicular, right? Okay, so if you go back to that parallel theorem, it said that you can pick a point anywhere on one of the lines and then do the perpendicular distance to the other one, right? This is kind of nice. What can I do here? I just count, right? So I could pick this point if you really want to, and I know the perpendicular is a vertical line, so I can just count from these two dots. Does everybody understand that? You could do the distance formula if you want to, but I don't know why you would, right? So let's count. 1, 2, 3, 4, 5, 6. Is that right? 6 units. So if we had the opposite, if we had had x equals something and x equals something, we still could have counted the horizontal distance that way, right? If there's any slant to it at all, we can't do that. But if it's a vertical or a horizontal line, we can. Super easy. Everybody's okay. Yes? Okay. The last question is obviously going to be the hardest. Find the distance between each pair of parallel lines to the given equations. I really think we need to graph this. I think that's the easiest way to do it. Most people are probably pretty good at y equals mx plus b, probably slope y or slope intercept form. So on this one, it's already ready to go. Y equals mx plus b. Everybody okay with that? What's m? 1/4. What's b? 2. So let's go ahead and graph that. And since we're trying to find the distance, I'm going to do it a bunch. I know that I only need 2 ordered pairs to make a line, but I'm going to do a bunch of them. Okay? So I'm going to start on the y-axis at 2 and go where? Up 1, right 4 a bunch of times, or down 1, left 4 a bunch of times, right? So up 1, 1, 2, 3, 4. Up 1, 1, 2, 3, 4. Up 1, 1, 2, 3, 4. I do it as many times as I can squeeze in there. So that one didn't fit for me, so I'm not going to do it. If I need it later, I'll come back, okay? So now I'm going to go down 1 and left 4 because 2 negatives make a positive, right? So it's the same. So down 1 and left 4. Is that 4? 1, 2. Sorry, it's hard to see the 1, 2, 3. Yeah. Down 1 and left 4. 1, 2, 3, 4. Down 1 and left 4. 1, 2, 3, 4. And I don't think that one will fit either, okay? So then you try to draw a straight line. And I have rulers if you guys really need them, but obviously the ordered pairs are really what we need, okay? So I've graphed that first line. I'm going to go ahead and label it, because if you don't label it, eventually this gets a little bit confusing. So y equals 1/4 x plus 2. I labeled it with what the name of the line was. Does that make sense? Okay. For the second equation, you could do x and y intercepts if you want to. That actually in an algebra question would be easier, but because we're trying to get as many ordered pairs as possible, I think slope intercept would be easier on this question, okay? So I'm going to try to get y alone because it's y equals mx plus b. So what's the first thing I'm going to do? Not yet. Yeah, add the x over, right? So 4y equals x minus 60. And then what? Divide by 4, right? When you divide by 4, you want to divide by 4 everywhere. Is that okay? So I get y equals, that's 1/4 x. Do you guys get that x over 4 is the same as 1 over 4x? Those are the same. And then what's 60 over 4? Negative what? 15? So what's my m? What's my slope? 1/4. What's my b? What's my y-intercept? Negative 15. Is everybody okay with that? And a good check for that was they told us they were parallel lines. If I hadn't have gotten the same slope, I would have known I did something wrong because they literally said they're supposed to be parallel. So if I didn't get the same slope, I screwed up. Okay? So we're going to start on the y-axis down 15, and we're going to go up 1, right 4 a bunch, right? So down 15, up 1, right 4, 4. There's other ways to do this other than graphically. There's algebraic ways, but in my opinion, most of the time that's harder. But if you're not a graphic person, if you'd rather do algebra, let me know later and I'll show you that method. Okay. So what we're trying to do is find the distance from this line to this line. Again, go back to what it said. It said pick a point on either line, any point you want, right? So I typically try to pick something easy. I'm going to pick that one. Why would I pick that one? Because there's a 0, right? 0 is usually pretty easy, right? You could have picked any point you wanted on any line. It doesn't matter at all, okay? So I have to find the perpendicular. What was the slope of this line again? Negative, yeah, sorry, just kidding. 1/4, that's a positive. So what's the perpendicular? -4. So from this point, I'm going to go down 4, right 1, and see where I hit this line. Does that make sense? Okay. Even I don't know if that's going to be nice. It may not be very pretty. I might have wanted to pick another one so it fit on my graph. But if it doesn't fit on my graph, I can show you the algebra instead. So let's try down 4, right 1. But I think we're going to be off, aren't we?
It's not yet.
It's off? Do you guys want to pick one that we know would be on, or do you want me to do the algebra? If you want one that's going to be on, I'm guessing maybe this one. Which one? 4, 3. This one makes it on? I would have thought that would be farther. If we go 1, 2, 3, down 4, right 1, down 4, right 1. It'll be on here, won't it? Yeah? Okay, let's go down 4, right 1. Let's see. 1, 2, 3, 4, right 1. 1, 2, 3, 4, right 1. 1, 2, 3, 4. Oh, yeah, this is fine. 1, 2, 3, 4, right 1. So please know, there's no wrong way to do it. Pick any ordered pair you want. Do the opposite flip slope. But it was nice that this was on here, so I didn't have to like go off my graph. If it goes off your graph, I'll tell you what to do instead. So what I'm looking for, is this distance here, right? I can't count that. Does everybody understand? That is not vertical, that is not horizontal, it's not an option, okay? So what I'm doing is I'm going to find the distance between, what's this ordered pair? 0, 2, and then find this one. 4, -14, is that right? Is that what you guys got? Okay, so I'm finding the distance between those two ordered pairs. So again, you can do distance formula, or you can do Pythagorean theorem trick. If you're going to do distance formula, go ahead and get started. I'm going to do this one probably Pythagorean theorem trick since I didn't do it on the last one. Okay, so if you're a formula person, go ahead and do your formula. Okay, let me get a different color. Let's try green maybe, I don't know. All right, so if I'm doing the Pythagorean theorem trick, I'm going to do sorry, gracious. Pretend that's a straight line and pretend that's a straight line. And we're looking for a question mark, right? So I need to find the length of this side and the length of this side. So this side looks like it's what, 1, 2, and then 14 more. So is that 16? Is that what you guys are getting? Yeah. And then 1, 2, 3, 4, I think. Okay, so if you do Pythagorean theorem trick, that's going to be 4 squared plus 16 squared equals I don't know squared, right? So what is 4 squared? 16. What is 16 squared? Use a calculator if you're not sure. 200 something. 256, good. And then what is 16 and 256? Yeah, 272. So that distance is square root of 272, which we have to break down in a second, but that's not really the point today, so I'm going to keep it there for just a second. People who did distance formula, does anyone need me to do that instead? You didn't get 272. You tried it that way and it didn't work. Are you sure? Everybody's with me? Okay, perfect. So we understand the concept then. The distance between those two lines, those 2 points, same thing, is the square root of 272. But an algebra 1 concept we can't forget is simplifying a square root. So if that had been like square root of 36, we would have said 6, right? This isn't a perfect square. You can put it in your calculator. It's not a perfect square. It's something like, this is an example, don't write it down. It's like the square root of 12, which is not a perfect square, right? But it has a perfect square in it. What's a perfect square that goes into 12 evenly? We got 1, 4, 9, 16, 25, 36, 49, right? 4 and 3. So back in algebra 1, you would pull that apart and be like, hey, that's really 2 square root of 3. So this is an algebra 1 concept that we're going to break down the 272. The only reason I showed you the 12 is because it's a smaller number. I think it's more manageable for you to remember the concept. So when you break down a square root, what you do is you divide by perfect squares, and you want the highest perfect square that goes into it evenly. So again, 4, 1 works, but it doesn't help. 4, 9, 16, 25, 36, 49, da da da, right? So start dividing by perfect squares and see what goes into it evenly. I heard someone say 16. Yeah? 16 and what? 17. What is the square root of 16? 4. So our final perfect, I get full credit, I totally understand what's happening answer is 4 root 17. If you left it here for now, that's like a half a point. It's not perfect, it's not done, but you at least got the concept. You did all that work and you just didn't break it down at the end. I get that, but eventually we need to make sure we remember how to simplify square roots. Are you kind of okay? I know that seems like a lot, but again, what I want you to tell yourself is, I know how to do distance formula or Pythagorean theorem trick. I know how to find the slope of a line. I know how to find the opposite flip slope. Do you see what I'm saying? All those little things you know how to do. It's just all shoved together in one big question. So you have to be super, super careful when you're doing these, because if you mess up anything, then it's wrong, right? Anybody have a question anywhere? Uh-huh. Uh-huh. Yeah. So keep in mind, it doesn't matter what ordered pair you pick. I could have picked this one, and I'm guessing the other one would have been that one. Like you could have picked anything. Does that make sense? You pick one, and then you follow your slope formula. I'm guessing this one to the other one. Okay? All right.